Welcome to IC Design for Wireless Systems. I am Abhishek Kumar, faculty in the Department of Electrical Engineering, Indian Institute of Technology, Hyderabad. In this course, we will understand how to design ICs for wireless systems. This course is for anyone who has taken an analog circuits course earlier and want to understand how to design a basic functional IC for wireless system. So here we can see a simple block diagram of how a wireless system module may look like. On the left side, this is an antenna which is receiving and transmitting radio waves, and this signal is fed to a radio module. So on a radio module, we can have various blocks present. So starting with a bank of switches and filters, which are needed to support various wireless standards. And then there will be a RFIC, which is predominantly containing RF and analog blocks. The RFIC is interfacing with a data converter module. And finally, the digital data is generated and received by a digital modem. So many times we will find that all these three modules, RFIC and the data converter and digital modem, can be actually presented on the same IC, and sometimes they are on different IC or different modules. So in this course, we'll focus on how to design this RFIC, which has mainly this RF and analog blocks. We'll see that in a wireless system, mainly we will be generating and transmitting these radio waves at high frequency for practical reasons. So the frequency will be of the order of gigahertz, and as a result of which, RFIC needs to also handle this high frequency electrical signals. So it needs to generate as well as receive these high frequency signals. So we will understand the architectures which will generate and receive these high frequency signals. Okay, so this is how we are going to start the course. And once you have got some basic idea about what kind of architectures will be present here, then we will move into the interface between the antenna and the radio module. This interface is really important because at high frequency, we will see that we can't just take any wire and connect the antenna to the module and assume that it will act like a short circuit. So in reality, we have to treat these connections as a transmission line. And in addition to this understanding of the transmission line, we will see that this connection has to be properly matched, which is coming from the antenna through the transmission line to the radio module. In addition to that, also the interconnections between these modules, especially at high frequency, has to be electrically matched. So we will also understand this concept of matching. Next, we will see that an RFIC mainly contains these three building blocks. There will be a receive chain, which will take high frequency signal input and generate an analog output. Then there will be a transmit chain, which takes the analog signal from the modem, and then it generates a high frequency radio frequency signal, which will be finally used to drive the antenna. And to be able to enable this conversion of frequency from high to low and low to high, we will see that we need a block called a local oscillator, which will help in doing this modulation to high frequency and demodulation from high frequency to low frequency. So when we need to understand these building blocks, it is important to also know how to characterize the non-idealities which may be present in a circuit in the context of designing this receive chain, transmit chain, and this local oscillator. Mainly, we will look into the non-idealities like non-linearity, which is present because all these building blocks will be designed using active devices. Those active devices have non-linear nature. In addition to the non-linearity, we will also see that any electrical circuit will also add an undesired signal called noise. And together this noise and non-linearity can reduce the fidelity of the signal which is being processed by the RFIC. And we will try to understand how to control them and how to characterize the effect of nonlinearity and noise. Fourth week onwards, we will start looking into the details of receive chain, transmit chain, and the local oscillator. So starting with the receive chain, we'll see what kind of building blocks are required to realize a receiver. And starting from, for example, a simple receiver may have a low noise amplifier followed by mixer, filtering, a variable gain amplifier to generate the baseband analog output. In addition to that, we will also look into some of the latest trends in the receive design. So one trend is with respect to how to implement and utilize and path filtering. Then there is a concept of noise cancelling low noise amplifier. And after getting an idea about how to design all these blocks at transistor level, we will move into the design of transmitter chain. And a transmitter, from the analog signal side, if we look at, so this analog signal is first received by a filter. This filter will be then driving a quadrature mixer, which will be finally generating a high frequency signal and powering the power amplifier, and this power amplifier will be driving the antenna. So in the transmitter design also, we will try to look into some latest trends. So there is a trend of using a radio frequency tag to directly generate RF signal from a digital input. Then there is a concept of digital PA, which is also similar to the RF tag, taking a digital input and generating a high frequency, high power signal. In addition, to improve the efficiency of the power amplifier, there are techniques like outphasing, which takes advantage of nonlinear high efficient power amplifier to generate a modulated signal. And regarding the local oscillator, we'll understand the concept of phase noise, and we'll look into the transistor level design of a voltage controlled oscillator. And finally, at the last week of the course, we will take a case study. This case study, mainly we will take an example of a Wi-Fi transceiver, starting from the specifications which are provided by the wireless standard. We will design a transistor level circuit for the various building blocks of receive chain, transmit chain, and also we will look into the local oscillator specifications. So hopefully by the end of the course, all of you will have an idea about how to design at least a basic functional wireless transceiver. Throughout the course, we will be doing a lot of hands-on exercises, which will require use of MATLAB as well as the SPICE simulators. So even if you don't have access to the proprietary tools, we can have the hands-on so that it can be done on free simulators like LT Spice and NG Spice. Enjoy the learning.